professor at LJ Institute of Engineering and Technology. Today we are going to study few more topics of Laplace transform. So let's begin with the first topic, that is inverse Laplace transform. Now if Laplace transform of ft is equal to f of s, then ft is called inverse Laplace transform of fs. Okay, and it is denoted as ft is equal to L inverse f of s. Okay, we'll bring this L over here, so we'll get ft is equal to L inverse f of s, where L inverse is called inverse Laplace transform operator. Now we will see the formula of inverse Laplace transform. Okay, now we know that Laplace transform of 1 is what? 1 upon s. Okay, so Laplace inverse of 1 upon s is what? 1. Now we know the Laplace transform of t raised to n is what? N factorial upon s raised to n plus 1, or n plus 1 upon s raised to n plus 1. Correct? So from this we'll get the Laplace inverse of 1 upon s raised to n. Here we have in the form of n plus 1. If we want to write in the form of s raised to n, it will be t raised to n minus 1 upon n minus 1 factorial, or t raised to n minus 1 upon gamma n. Okay, then Laplace transform of e raised to at is what? 1 upon s minus a. So Laplace inverse of 1 upon s minus a will be e raised to at. Similarly, Laplace inverse of 1 upon s plus a is e raised to minus at. Laplace inverse of 1 upon s square plus a square is 1 upon a sin at. Laplace inverse of 1 upon s square minus a square is 1 upon a sin hat. Laplace inverse of s upon s square plus a square is cos at, and Laplace inverse of s upon s square minus a square is cos hat, and Laplace inverse of 1 is delta t. Okay, now we'll use this formula and we'll solve few examples. Now let's solve an example. So here we have to find Laplace inverse of 1 upon under root s, that is s raised to 1 by 2. Okay, so we will use this formula of Laplace inverse of 1 upon s raised to n is what? Here t raised to n minus 1 upon gamma n. We are using this formula because here n is 1 by 2. If n is natural number, we'll use this formula, that is t raised to n minus 1 upon n minus 1 factorial. Okay, now we will use this formula. So it is t raised to n minus 1. In place of n, just write down 1 by 2. So here you will get this type of form. Just simplify this. So this is t raised to minus 1 by 2, and we know the gamma 1 by 2 is what? Under root pi. So Laplace inverse of 1 upon under root s is what? T raised to minus 1 by 2 under root pi. Okay, now let's discuss one more topic, that is first shifting theorem. So the statement is, if Laplace inverse of fs is equal to ft, then Laplace inverse of fs minus a is what? E raised to at ft. Okay, now second shifting theorem. If Laplace inverse of fs is equal to ft, then Laplace inverse of e raised to minus a as fs is ft minus au t minus a. Okay, so you have to remember both the formula. Now let's solve example. So first we have to find inverse Laplace transform of s plus 2 upon s square minus 4s plus 13. Okay, so what we will do in this type of example, we will find the last term, okay, of this term, and then we will apply this a plus b or a minus b whole square formula. So to find the last term, what we have to do, we have to apply this formula, that is middle term square upon 4 into first term. Okay, now middle term is minus 4, so its square is what? 16 upon 4 into first term, your coefficient is 1, so we have 1. Okay, simplify, so this is 4. Okay, so your last term is 4, and we have plus 13. Okay, so to balance it, what we will do, we'll apply this minus 5. Now s plus 2 as it is. Okay, so from here what we will get? S minus 2 whole square. Okay, and from here we will get 9. Now here we have s minus 2, so what we will do, we'll try to make s minus 2 in the numerator. Okay, so for that what we need? S minus 2. So firstly we'll write down s minus 2. Okay, now if we are writing minus 2, so we have to write plus 2, and we have already 1 plus 2, so this 1 plus 2 as it is. Okay, and here s minus 2 whole square plus 9 as it is. Now Now what we will do, we'll take this s minus 2 and this denominator. So we have s minus 2 upon s minus 2 whole square plus 9. Okay, and we will split this. So from here 2 plus 2 it will give you 4. So 4 upon s minus 2 whole square plus 9. Now, what we have to do, we'll take this first minus 2 outside, okay? So it will come e raised to 2t, okay? And what will remain is, just ignore this minus 2. So Laplace inverse of s upon s square plus 9. 9 we can write as 3 square, okay? Now again over here also we'll take this minus 2 outside, so it will be e raised to plus 2t, right? And we have Laplace inverse of this 4 is constant, we'll take it outside, right? And here 1 upon s square plus 3 square. Okay, now here we have s in the numerator, so this is the cos formula. Okay, and here we have 3. So what you will get, e raised to 2t, Laplace inverse of s upon s square plus 3 square, it will give you cos 3t, correct, plus 4 e raised to 2t as it is. Now here we don't have s, so we have to set a, right? Now a is 3, so what we will do, we will multiply and divide it by 3, right? So answer of this Laplace inverse, 3 upon s square plus 3 square, it is what here, 4 upon 3, this is sin 3t. Okay, so final answer of Laplace inverse of s plus 2 upon s square minus 4s plus 13 is what, e raised to 2t cos 3t plus 4 upon 3 e raised to 2t sin 3t. Okay, so this example we have solved using first shifting theorem. Okay, now let's solve one more example. Find Laplace inverse of e raised to minus 3s upon s square plus 8s plus 25. Okay, now whenever this e raised to minus 3s is present, okay, so we will use this formula, e raised to minus as fs is what, ft minus a ut minus a. This is second shifting theorem. Okay, so we will use this formula. So for that, what we will do, first we will find Laplace inverse of this fs. Okay, we need ft first. So first we will find Laplace inverse of fs, and fs is what here, 1 upon s square plus 8s plus 25, right? Now whenever we have this type of question, what we'll do, we'll find last term every time. Okay, so again last term is what, middle term square upon 4 into first term. Okay, now here middle term is 8. Okay, so it is 64 upon 4 into first term is 1, right? So this answer is what, 16. So this is Laplace inverse of 1 upon s square plus 8s plus 16. Now as we are adding 16, so we'll subtract also. Okay, now just simplify this. So 1 upon, now this is what, this is s plus 4 whole square. You can simplify and verify. This is s square plus 8s plus 16, correct? And from here we'll get 9, right? Now we have this type of form. Okay, we don't have s over here, so it will become a sine formula, correct? Now first what we will do, we will take this plus 4 outside. Okay, so if we are taking this plus 4 outside, it will be e raised to minus 4t, right? And what will remain is Laplace inverse of 1 upon s square plus 9. Now 9 is what, 3 square. Okay, so what we will do, we'll multiply and divide it by 3. So e raised to minus 4t upon 3, and Laplace inverse of 3 upon s square plus 9, it will give you sin 3t. Okay, so this is the Laplace inverse of this. This is your ft. Now uh, the formula is what, Laplace inverse of e raised to minus as fs is ft minus a ut minus a. Okay, so Laplace inverse of e raised to minus 3s upon s square plus 8s plus 25 is what, now here a is what, 3. Okay, so in place of t, what we will write, t minus 3 everywhere over here. In ft, in place of t, we will write t minus 3. So what you will get, e raised to minus 4 t minus 3 upon 3 sin 3, as it is, in place of t we will write t minus 3. Okay, and we have to write this ut minus a. Okay, so this is ut minus 3. So this is the final answer of this Laplace inverse. Correct? Now let's begin with another method, that is method of partial fraction. Okay. Now we will solve the Laplace inverse using partial fraction. So suppose if we have this type of fraction, that is 1 upon s minus a s minus b. So we can write it as a upon s minus a plus b upon s minus b. Okay. We will simplify this and we'll find a and b, and then we will apply Laplace inverse formula. Okay. Now when the roots are linear and repeated, so the roots are linear. Whenever we have the power of s is 1, it is called a linear. Okay, so here we have the linear roots and they are repeating. Okay, so we will write this as a upon s minus a plus b upon s minus a whole square plus so on. Okay, now up to, if we have suppose cube, so we have to go up to 3. If we have power 4, so we have to go up to power 4, like that. Okay, now if we have a quadratic and distinct factor, now the power of highest power of s is 2, so this is known as quadratic. Okay, and we have two distinct factors, so we can write it like this: as plus b upon this term, okay, plus cs plus d upon this term. So whenever we have a linear term, we will write constant about to it. Okay, if we have a quadratic, we will write a linear term about to it. Okay, then we'll find this constant a b c d, will substitute it, and then we will find Laplace inverse. Now when the factors are quadratic and it is repeating, okay, so we have like this 1 upon s square plus as plus b whole square. Okay, so similarly like this we will write it as plus b upon s square plus as plus b. Now here we have whole square, so we will go up to whole square, right? So cs plus d upon s square plus as plus b whole square. Now again same method, we have to find a b c and d, and on substituting and simplifying will be able to find Laplace inverse. So let's solve few examples so this topic will be clear to you. Now we have to find Laplace inverse of 1 upon s plus under root 2 and s minus under root 3. Okay, now you can see we have two linear factors and both are different. Okay, so this 1 upon s plus under root 2 s minus under root 3, okay, this we can write as a upon s plus under root 2 plus b upon s minus under root 3. As you can see, we have linear term, we are writing constant about to it. Now just cross multiply, so here we have a into s minus under root 3 plus b into s plus under root 3 upon this s plus under root 2 and s minus under root 3, and over here we have 1 upon s plus under root 2 and s minus under root 3. This two denominator will get cancelled, and what remains is 1 is equal to a into s minus under root 3 plus b s plus under root 3. Okay, now here we have under root 2. Okay, now in order to find this constant a and b, what we'll do, we'll take s is equal to root 3 first. Okay, then we'll take s is equal to minus under root 2. So if you will take s is equal to root 3 and substitute over here, so this term will be gone. Okay, and what remains is 1 is equal to b into under root 3 plus under root 2. Okay, so from this you will get b is equal to 1 upon under root 3 plus under root 2. Correct? And to find another value, what we will do, in place of s we will write minus root 2. So if you will write minus root 2, this term will be gone. Okay, and what remains is 1 is equal to a into minus root 2 minus root 3. We can take this minus common. Okay, so a will be what, minus 1 upon under root 2 plus under root 3. Okay, so in place of this, okay, what we will do now, in place of a will write minus 1 upon under root 2 plus under root 3, and in place of b will write 1 upon under root 2 plus under root 3. So you will get now 1 upon s plus under root 2 s minus under root 3 is what, a. In place of a we have minus 1 upon under root 2 plus under root 3, and here we have 1 upon s plus under root 2. Okay, plus in place of b we have answer 1 upon under root 2 under root 3. Okay, and here 1 upon s minus under root 3, right? Now we'll apply the Laplace inverse. So Laplace inverse of this term will be what, Laplace inverse of this term also. Okay, now this is constant, so we can take it outside. So 1 upon under root 2 plus under root 3 outside. Laplace inverse of 1 upon s plus under root 2. Clear? Again, this is constant, so we'll take it outside. So root 2 plus root 3 and Laplace inverse of 1 upon s minus root 3. Okay, now minus 1 upon root 2 plus root 3 as it is Laplace inverse of this term. Okay, now we know Laplace inverse of 1 upon s plus a is what? E raised to minus et, right? So here what we'll get? E raised to minus under root 2t plus 1 upon this under root 2 plus under root 3 as it is. Okay, and we know the Laplace inverse of 1 upon s minus a is what? E raised to at. Okay, so from this we'll get e raised to under root 3t. We can take this 1 upon root 2 plus root 3 common. Okay, so we have minus e raised to minus root 2t plus e raised to under root 3. So this is your final answer. Okay, now let's solve one more example. So we have to find Laplace inverse of this term. So Laplace inverse of here 4s plus 5 upon s plus 2s minus 1 whole square. Okay, now you can see in denominator we have linear term, but this s minus 1 is repeating. Okay, so how we will write this? Upon s plus 2 upon s minus 1 whole square. Now this is a linear term and it is not repeating, so first we will write this as a upon s plus 2. Now this is repeating, so we will write as b upon s minus 1. Now we have whole square, so we will go up to whole square. So c upon s minus 1 whole square, like this. Okay, now again what we will do, we'll cross multiply it. Okay, so here what you will get? A into s minus 1 whole square. Okay, now b into, just multiply s plus 2, so s plus 2 into s minus 1, and over here we'll have c into, we have only this s plus 2, so c into s plus 2. Now this denominator with this denominator will get cancelled. Okay, and what remains is here 4s plus 5. Now s will be 0 for 1 and minus 2. So firstly we will solve for s is equal to 1. Okay, substitute s is equal to 1 over here. So this term is gone, this term is gone. From here we'll get, and also we have to substitute over here also. Okay, so 4 plus 5 is equal to, these two terms are 0, and here if you will substitute 1, so we will get 3c. Okay, so 9 is equal to 3c, so c is what? 3. Correct, so this is the answer of c. Now next we will substitute s is equal to minus 2. Okay, now if you will substitute s is equal to minus 2, this term will be gone, this term will be gone. Okay, we'll get answer from this 2. So substitute minus 2 over here, so we'll get minus 8 plus 5, okay, is equals to, here minus 2, so minus 2 minus 1, that is minus 3. Okay, and minus 3 square, so we will get 9a, right? Now this is minus 3 is equal to what? 9a. So what will be the answer of a is minus 3 upon 9, that is minus 1 upon 3. Okay, so answer of a is what? Minus 1 upon 3. Next, now what we will do, we'll substitute, we'll take s is equal to 0. Okay, so if you will substitute s is equal to 0, we have to substitute everywhere. So first substitute s over 0 over here, so from this we will get 5, okay, is equals to, now 0 substitute 0 over here, so minus 1 square, it will give you 1. Okay, so from here we have a plus, now substitute 0 over here, so 2 into minus 1, it will give you minus 2. Okay, so now here we have minus 2b, okay, and plus, from here we'll get 2c. Now we know the answer of a and c. Okay, so substitute the answer of a and c, so this is minus 1 upon 3 minus 2b plus, in place of c we have to substitute 3, right? So this is 3. So from here what will be your 2b? Just bring this 2b over here, so minus 1 upon 3 minus 5 plus 6. Now on simplification you will get b as 1 upon 3. Okay, so we will substitute the answer of a, b, c over here. Okay, and what you will get, will write, so Laplace inverse of that question over here, okay, is equals to, now in place of a, let's see what is the answer of a. The answer of A is minus 1 upon 3. So minus 1 upon 3 into 1 upon s plus 2. Okay, plus now let's see the answer of B. So answer of B is 1 upon 3. So 1 upon 3 into 1 upon s minus 1. And the answer of C. So answer of C is 3. So 3 upon s minus 1 whole square. Okay, we have to just substitute the answer of A, B and C. Now we have to find the Laplace inverse. Okay, so Laplace inverse will be what? Now minus 1 upon 3, as it is Laplace inverse of 1 upon s plus 2, that is e raised to minus 2t. Okay, plus 1 upon 3, as it is Laplace inverse of 1 upon s minus 1 is e raised to t. Now 3 as it is. Now to solve this, what we have to do, we have to apply first shifting theorem. Okay, so first we will take this minus 1 outside, so it will give you e raised to t, and Laplace inverse of 1 upon s square. Okay, just simplify further. So minus 1 upon 3 e raised to minus 2t plus 1 upon 3 e raised to t plus 3 e raised to t. Now Laplace inverse of 1 upon s square is what? T, right? So this is your final answer. Now let's solve one more example. So we have to find Laplace inverse of 5s plus 3 upon s minus 1 s square plus 2s plus 5. Okay. So now you can see that here we have one linear term and one quadratic term. Okay. So this is 5s plus 3 upon s minus 1 s square plus 2s plus 5. So whenever we have the quadratic term, linear term, so firstly for the linear term we will write a upon s minus 1. Okay, and for quadratic term we will write bs plus c upon s square plus 2s plus 5, like this. Okay, now whenever we have this type of combination, okay, what we have to do, we have to cross multiply it. Okay, so first cross multiply and multiply this a2 bracket. Okay, so a square plus 2as plus 5a. Okay, and we will multiply this s minus 1 to this, so s minus 1 into bs plus c is equal to what? 5s plus 3. This denominator will get cancelled. So from this we have as square plus 2as plus 5a. Now multiply this 2. So what you will get? Bs square. First multiply s. So you will get bs square plus cs minus bs minus c. Now what we will do? We will take these two together. Okay, and we'll take s square common. So a plus b s square. Now we'll take this term, and this term together. Okay, so from this we'll get 2a plus c minus b into s. Okay, and lastly we will take these two constant together, that is 5a minus c. Okay, and here we have 5s plus 3. Now what we will do, we'll compare the coefficient of s square, s and constant. Okay, now you can see on the left hand side we don't have s square. Okay, so coefficient of s square is 0. So from this we will get a plus b is equal to 0. Next, the coefficient of s over here is what? 2a plus c minus b, and this is equal to, what is the coefficient of s over here? 5. So here we have 5, and at last the constant, that is 5a minus c is equal to what? 3. Clear? Now what we have to do, we have to simplify this 3 equation and we have to find the value of a, b and c. Okay, so from this we can say that what is c? C is what? It is 5a minus 3. Okay, now in place of c we have to substitute 5a minus 3. So 5a minus 3 minus b is equal to 5. Alright, now simplify this. So 7a minus b is equal to what? 8, and here we have a plus b is equal to 0. So we'll take this a plus b equal to 0 and 7a minus b is equal to 8. Okay, so from this we'll get 8a is equal to 8. So we'll get a is equals to 1. If you will substitute a is equals to 1 over here, so you will get the answer of c as what? 2, correct? And substitute a is equal to 1 over here, so 7 minus b is equal to 8. Okay, so b is what? Minus 1. So this is the answer of A, B and C. Now we have to substitute the answer of A, B and C over here. Okay, and then we have to find Laplace inverse. So in place of A, firstly we'll substitute 1. So we have this Laplace inverse of this question, okay, is equal to, answer of A is what? 1. So 1 upon s minus 1, okay, plus this denominator. So what is the denominator? First we will write the denominator, that is s square plus 2s plus 5, s square plus 2s plus 5, okay, and in numerator, in place of this b, we have to write minus 1, in place of c, we have to write 2. So what you will get? 2 minus s, correct? Now, we have to find Laplace inverse. So here we have Laplace inverse, right? Now what we'll do? Laplace inverse of 1 upon s minus 1. Now as we want positive, so what we'll take? We'll take minus outside. So what you will get here? S minus 2 upon s square plus 2s plus 5. Clear? Now, Laplace inverse of 1 upon s minus 1. Now, again to solve this type of example, what we have to do? We have to find the last term. Okay, so again, last term formula is what? Middle term square upon 4 into first term, right? Here middle term is 2, so it is 4 upon 4 into first term is 1, right? So last term is 1 over here. So s minus 2 upon s square plus 2s plus 1. Now as we have added 1, so we have to subtract 1. Okay, so here 5 minus 1. Now Laplace inverse of 1 upon s minus 1 minus s minus 2 upon. Now from this we can write it as s plus 1 whole square. Okay, and here we have 4. Now again same process. What we have to do here, we need s plus 1. Okay, so we will write s plus 1. To balance it, what we have to do? We have to subtract 1. So minus 2 minus 1. Okay, and here s plus 1 whole square plus 4. Right? Now what we'll do? We'll take this s plus 1 and this denominator and this minus 3 and this denominator. Okay, so you will get Laplace inverse of 1 upon s minus 1 minus s plus 1 upon s plus 1 whole square plus 4, and this minus 3. Okay, so minus minus will become plus, so 3 upon s plus 1 whole square plus 4. Okay, now to solve this, we have to solve this too, we have to apply the first shifting formula. We can solve this easily. Okay, so answer of this is what? E raised to t minus, now plus 1 will be outside, so it is e raised to minus t, and what remains is Laplace inverse of s upon s square plus 4. We have to just ignore this plus 1 and write other terms. Okay, plus 3, again we'll take this plus 1 outside, so e raised to minus t, and what remains is Laplace inverse of 1 upon s square plus 4. Okay, now 4 is what? 2 square, so to here we'll write it by 2 and we'll divide it by 2. Okay, now at last your final answer will be what? E raised to t minus e raised to minus t. Laplace inverse of s upon s square plus 4, it is cos 2t. Okay, plus 3 by 2 e raised to minus t, and Laplace inverse of a upon s square plus a square is sin 80. Okay, so from here we'll get sin 2t, right? So this is your final answer. So I hope you have understood throughout the section. Thank you for watching.